And now the rational functions review for the cumulative number 3. So on the cumulative test, you hit the rationals over again, and let's see if you remember how to factor, because that's going to be huge. Because if you can factor it, you should. Let's see if you can handle this one. X to the third plus, let me think, 5x squared plus 4x. There we go. Now, made that a little bit more challenging than normal. Factor the top, factor the bottom, and then see what cancels. When you're done, simplifying it, if it was an R2, it might just be as simple as simplify this. If it was a higher level question, they might ask you its domain. Remember that thing that starts with all reals? And they might ask you for the vertical asymptotes. Remember, the things that kill your domain are the things that are either verticals or they're holes. And if there's a hole, you have to tell me exactly where it is. And last but not least, the horizontals, and those are the ones that Bob tells you about. 2-second review on that. If it's bigger on the bottom, like, x plus 3 over x squared, that's got a bigger degree on the bottom, then it's a y equals 0 plus whatever's on the outside. If this had been moved up like 8, it'd be 0 plus 8 would make 8. All right, what if it's bigger on the top? If it's bigger on the top, that means that it's like x squared plus 3 over x, and that's got a bigger degree on top. Bots have no horizontal asymptotes, so no bots, kind of like robots. And then the last one is same on both. I was amazed at how many people got this one wrong on the test. Let's say it was like this, and you had a 2x plus 7 down here. If you can factor it, you should. You end up factoring out the top, but the lead coefficients are still here and here. And this is supposed to be same on both. Oops, I better make this be like squared down here. There we go. Now it's the same on both. And so now this one, for a same on both, you find the ratio of the lead coefficients, which are the 3 and the 2. So your equation would be y equals 3 halves. So there's this kind, and then Bob's are y equals 0 plus whatever's on the outside. All right, so there's a quick review of those horizontal rules. I think that was one of the things that kids missed the most. So let's go back up to this problem. I'm going to give you a minute and see if you remember how to factor this and then figure out all those things: domain, verticals, holes, horizontals. And I'll pause for a bit. Okay, let's see how you did. First off, I would hope you'd factored it to x plus 4 and x minus 4. Because if you can factor it, you should. And down here we have x coming out, x squared plus 5x plus 4. And now I'm going to factor this part again. This part would be x plus 4 and x plus 1. Now, here, I'll bring the x back down again, so that's gone too. Okay, now we have this on top and this on the bottom. And will anything cancel? That's critical. Yes, something will cancel. This part right here cancels this part, and that makes something important. All right. Now I'm going to summarize what I have left. I call it the resulting function. The resulting function here is y equals, probably should have put that there too, y equals x minus 4 on top, and on the bottom, x times x plus 1. Okay, now the domain. Domain is all real numbers except x, there we go, cannot equal these 3 things, the 3 things that would make it crash, because would make the bottom 0. X cannot equal 0, x cannot equal -4, and x cannot equal -1. Now, those 3 things, this, and this, are either holes or vertical asymptotes. Now, the one that canceled here, that and that makes a hole. And the hole is at -4, comma what? Well, I put the -4 into the resulting function right here. And now I have -8 on top over -4 times negative 4 plus 1, which makes negative 3. Negative 3 times negative 4 is positive 12. I can simplify that to, let me think, 4/3, negative 2/3. There we go. Okay, so there's my hole at negative 4 comma negative 2/3. How about the asymptotes? So there's verticals and there's horizontals. Remember, these are either asymptotes or they're holes. And we just figured out that one was a hole, which means the other two things that crash the function, x cannot equal 0. So x equals 0 is an asymptote line. And same with x equals negative 1 is an asymptote line. Okay, now the horizontal asymptotes. That's the bigger on bottom, bigger on top, same on both kind of rules. This one's bigger on the bottom. And since it's bigger on the bottom, it's a y equals 0 unless there's something on the outside. And there isn't. So there we go. Okay, now, could they flip this on you and say, instead, I'm going to tell you the domain. The domain is all reals except x cannot equal negative 3 and x cannot equal 3. And what if they told you the horizontal asymptote was y equals 0? And then I'd be thinking to myself, okay, well, which one does that mean? Does that mean it's bigger on bottom, bigger on top, or same on both? Okay, anyway, then let's say that the vertical asymptote was at x equals 3. And then, lastly, that there was a hole. And the hole was at negative 3, comma, and I'm not going to tell you what, because that would make your problem actually too complicated. But you could now make me a function that has to have all these things. Probably have some stuff on the bottom like this, maybe some stuff on the top too. Some things will cancel. All right, I'd like you to tell me what the original problem would have been that would have had these results. This kind of domain, this kind of horizontal, vertical, and hole. I'm going to pause for a second while you give that one a try. Okay, first thought, as you're working this out, I hope you realize that those things would crash this function. And therefore, x plus 3 goes with this one, and x minus 3 needed to be on the bottom. Now, you could have multiplied that out and said x squared minus 9, but you didn't have to. Next, if this is y equals 0, horizontal is the one that Bob tells you about, then is it a Bob, Sob, or a bot? Well, I'll tell you what it can't be. Can't possibly be a bot because bigger on top, the bigger on top kind, have no asymptote. Bigger on bottom is the one where y equals 0, and so this one must be bigger on the bottom. That means whatever I do, I need to make sure the bottom has a bigger degree than the top does. So I don't really want two factors up there, or I might end up with it being same on both. So, all right, next, to get a vertical asymptote at x equals 3, that's going to be this one. That means that better not cancel. But to get a hole at x equals negative 3, can you think of what I need to do in that top parenthesis? Anyone? Yeah, put in x plus 3 up there, and that'll make this into a hole that would cancel out. All right, so there is your original function. It would have the domain we want. It would have bigger on the bottom, so y equals 0. We'd have a vertical of x equals 3. That's for this part. And it would have a hole at negative 3 comma something. In fact, we could figure that out. The resulting function on this would be 1 over x minus 3. And we could figure out that it was negative 3 comma, well, we could put in a negative 3 down the bottom there and get 1 over negative 6. But that wasn't required. We were trying to write this function, and we got the function. There it is. Okay, let's try another one like that. This time, the domain's going to be x equals negative 4 and x equals 7. And our horizontal asymptote is going to be none. Our vertical asymptote is going to be at 7, or so I should say x equals 7. Oh, and I wrote this wrong. All reals except x cannot be this and x cannot be that. Okay, sorry about that. And now the vertical was at x equals 7, and a whole at -4 comma something. All right, I'm going to pause for a second while you try to write a function that would have all these answers. Okay, so thinking, you probably know this is a fraction function, a rational function. And so the domain is helpful. It tells us that these two things, x plus 4, so that -4 would crash it, and x minus 7, so that positive 7 would crash it, those things must be on the bottom. Next, the horizontal asymptote being none. What does that mean again? Bigger on bottom, bigger on top, same on both. The kind that has none is the bots. So this one must be bigger on the top. So we better put a fair amount of stuff up here so that it will be bigger on the top. All right, next thing is the vertical asymptote. Vertical asymptote is going to be at x equals 7. That means what we can't do is this. Otherwise, we're making a hole at 7, and we don't want that. All right. Next is the hole is at -4. If the hole's at -4, then this must be on top, hence creating the hole at -4. Okay, now exactly what needs to be in these other two parentheses, honestly, you can have a lot of different things in there because it doesn't say anything about, you know, we couldn't have a 9 up there or x minus 8 up there. That's kind of like anything you want up there, as long as it has x's in it, so that this has degree bigger than this. Because remember, we want it bigger on the top so that we would have no horizontal asymptotes. Because that's the rule for bots, is no bots. If there's no asymptotes, that means it's bigger on top. All right, so this, again, what's in here or here is kind of your choice, as long as they didn't make holes out of these things. So again, you couldn't put x minus 7 up there. Otherwise, you would have created a hole right there. So, okay, next thing. What if they give you one of these where it's got a hole in it? Well, first of all, the best tip is to act like it doesn't have a hole in it. Just act like this equation, you just need the equation for this thing. Let's say that that's hitting at 4. And let's say that it has a slope is 1/2. Act like it doesn't have a hole. I'm just covering this up. What's the equation for this without the hole? Now, a lot of you guys tried to wing this on the tests, and you did not do so well at it. I saw a lot of people who would start with y equals, and then they'd say, okay, well, I want this to be a line, but it's got to have the hole, and you'd put the hole in there too early, and then you'd put like +4 out here because you thought, well, this is going to have a +4 on as its y-intercept. No, 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 no. What did I say in class? I said start by acting like there is no hole and just figure out the equation for that line. All right, well, this line is y equals mx plus b. And the m, the slope is a half. And therefore, that's 1/2 x. And then plus b, that's +4. Now, this is important. That needs to go in parentheses, so that when we put other parentheses in with our hole, that it ends up working out just right, so that when these cancel, we're left with exactly 1/2 x plus 4. Again, a lot of kids put the +4 like over here somewhere, and then they had the hole canceling out in here somewhere. You can't do that. I suggested that you put them in parentheses like factored form like this. And then you can put in the rest. Okay, now, where is that hole? After all that avoiding the hole, now we got to actually pay attention to it. Let's say that it's over 4 spots over. That 4 is a terrible number because we just used that a second ago. hold on. Let me make that. There, we'll make it 3 spots over. Okay. So then you would say x minus 3 and x minus 3. Okay. That makes the whole at 3. People get these opposites kind of confused in their head. Remember that 3 needs to make that equal 0. So it needs to be x minus 3 over there. All right, so there's a good equation for this line that has a hole in it. Let's have you try one. Let's say I had this, make it like this, hole right there keeps going. Say that this is -2. Let's say that this is hitting at 6. And let's say this guy's slope, actually it looks more like 4, sorry. Let's say this guy's slope is -2. Can you write me the equation that goes with this black line that has the hole in it? Pausing while you give that a try. Okay, hopefully you thought y equals mx plus b, the slope, -2x, and the the y-intercept, the b term, is 4. Okay, that spot right there was 4. So now I put that in parentheses, and then a point that's going to cancel. That's going to make the hole right above -2. So then this is x plus 2 and x plus 2. That creates the hole at -2. And then our resulting function after that hole disappears would just be this. Okay, so this whole answer, this whole thing is your answer, and you shouldn't have it canceled. Just having a hard time getting that x out of there. Okay, and one last one. Let's do one where we need to graph it. All right, so let's take this, x plus 4, and then on the bottom, let's make it x squared minus 16. Let's have you graph that. I'm going to pause for a second and give that a try. Okay, so hopefully you factored, well, the top's already factored. I'm going to factor the bottom, x plus 4 and x minus 4, and that will cancel that, leaving y equals 1 over x minus 4 as your resulting function. If I graph that, I happen to know that that is a butterfly function that has been moved which way? -4. What does that mean? Right 4. Okay, there, I moved it over right 4. Now the asymptote would go right about here. And then the other asymptote would go right about here. And then, if I were to put in the hole, you gotta be careful with where that is. This created the hole, so x equals -4 is the crucial spot. So I go over here to where x equals -4. And then right underneath that, there's going to be an empty spot, and then it's going to keep going. All right, it should get closer and closer to that asymptote, so I kind of maybe head towards the asymptote. This is getting closer and closer to the asymptote too. Has a couple key points right here and right here. Okay, so there's a review of a lot of the things you might need for your cumulative. I have one last thing I'd like to throw at you. Let's say that I had this. X to the third plus 2x squared plus x all over x squared minus x. I did one like this before break with you, just to see if you could catch what happens with all those x's. To get on the top, an x factors out of everything, and I'm left with x squared plus 2x plus 1. And on the bottom, an x factors out of both of them. And I have x minus 1. Now, if you can factor it, you should. And the top can factor further. This part can factor into x plus 1 and x plus 1. So I'm going to rewrite that. X, and then x plus 1, and then x plus 1. And on the bottom, I have x, and then x minus 1. For some reason, people have trouble seeing these x's. That's just a hole, like it would be if this was an x plus 1, I would have canceled it with this. but it's not, so I'm not gonna. But this does make a whole because these cancel. And that's x equals 0 is the whole, so 0 comma what? You just stick 0 into the resulting function, which goes in here, here, and here, and you get 1 times 1 is 1 over negative 1, which makes negative 1. 0 comma negative 1 is where the whole would be. All right, so if there was another whole, there can be like multiple holes. Let's say that this had an x plus 7 on the bottom and an x plus 7 on the top. That would also created a hole at negative 7. So that's just a reminder on how to do some weird factoring that involves finding holes. Okay, and that's all I have for you for your review for the cumulative, and I'm going to now give you over to your study habits, and I strongly encourage you to Dropbox the review into the Dropbox. That's the kind of thing I can use to help judge whether you really tried hard for this cumulative test. And when I'm making those judgment calls at the end about does this kid deserve a break because they got really close to this grade or that grade, trying hard matters. Okay, good luck on your test tomorrow, and I'll see you again real soon. Take care. Bye-bye.